As we are studying about graphical representation of motion, now we have to see the new type of graph. We studied distance time graph. Now we are going to study velocity time graph. So I put some values over here. Say initially the body did not have any velocity, then or let us say it had 50 meter per second velocity. When I was watching it, it was already going, and I just oh, that car is going, and I have a speedometer. I said 50 meter per second. After 2 seconds it was 100 meter per second. After 4 seconds it was say for example 150 meter per second, and after 6 seconds it was 200 meter per second, and lastly it was 250 meter per second, like that. All right, let us see. So that is how it is going. So let us see what will happen this time. So let me check the details here. 50, 100. So to get it now. So I am putting over here. Time is 2 seconds. It's right. 4, 6, 8, and 10. And now I'll take this as 50 meter per second. Then 100 meter per second. Then 150 meter per second. Then 200 meter per second, and then 250 meter per second. This is what is a graph. So meter per second, this is a velocity graph and velocity time graph. So now what happens? Let us see. At 0 it was already having a velocity. Then after 2 seconds it had 100 meter per second. Then after 4 seconds it was 150 meter per second. Then after 6 seconds it was 200 meter per second, right. And after 8 it was having 250 meter per second. So when I plot it on a graph, then if I join all the points, what do I get? When I join all the points, so I get a slope. So if an inclined straight line on a velocity time graph means the body is having uniform acceleration. It is increasing its speed, but with a uniform rate. It's like so it is changing its speed with a uniform rate. So we will find out that the slope of a velocity time graph will give acceleration. Because you know what happens, suppose at 8 I am putting this at exactly 8 seconds, 8 should be somewhere here. So exactly 8 seconds I am putting this. So I am watching this, it is touching over here after 8, say for example. So after 8, so slope always means you should have a triangle, so I drop this. So now from here to here, A to B, what is happening? You are measuring change in velocity. It was 50 initially, see this is 50, and it became 250. That means it changed its velocity to 200 meter per second. That means 250 minus 50. So 200 meter per second it changed its velocity divided by the time. So it changed from 0, that means 2, 4, 6, 8 in 8 seconds. So now what is the change? 25 meter per second square. So that is the acceleration. We have got the acceleration. So in any velocity time graph, the slope, that means you have to have the perpendicular and the base. So that means you have to always complete a triangle, and you have to take this length by going this way. So it is 200, 250 minus 50, 200, and you have to place the time, and then you get. And you know, when you get the area of this graph, you will know how much distance it has covered. So area, distance covered will be given by area of the graph. Covered will be equal to area of the graph. Now how do you find the area? Let me see. How do you find the area? You find the area here. There is a rectangle. So rectangle area is length into breadth. So this is 50 meter per second. That means it's in correct unit, and this side it is in second. So 50 into 8. So 400 meters it has gone, plus the area of this part, this triangle, the larger triangle. So the larger triangle, the area will be how much? Half base into it. So the base is 8 and height is how much? This height already we have calculated, 200. So it becomes 400 plus 800, that is equal to 1200. So distance covered is 1200. So velocity time graph, the slope gives acceleration and the area gives distance, area of the graph, total area of the graph. Otherwise, the part which it covered during its acceleration is only 1200 meters. The part which it covered during its uniform velocity, then it will be 400. That is the way you have to go. Now let us see here what happens next. Here the body in 0 second it was here, so okay. After 5 seconds it had 20 meter per second. After 10 seconds it was 60. And after 15 it was 120. And after 20 it was only 140. So it was just here. So let us see how did it change. So the graph if I put, then it shows a curved line. So for velocity time graph, a curved line means the body is having non-uniform acceleration. That means unequal change in velocity in equal interval of time. And here equal change in velocity in equal interval of time. That is very, very important. Now suppose I have a velocity time graph, you have to use your common sense. Don't memorize that if this will be there. See velocity and time graph. Now suppose they give you a straight line. So in your mind keep some value over here. You give 50 meter per second and give time 246 like that. So time is increasing but the velocity is not changing. That means what is the type of graph? The graph is the body is moving with uniform velocity and you have to use the term acceleration. Then the body is moving with, you say, zero acceleration. When in velocity time graph there is a parallel line to time axis, that time the body is not changing its speed. So next is, suppose I go this way. So what is happening now? At 0 second body was having some speed. Now suppose I say right in the middle. After 10 seconds the body speed decreases, and when it came to 0 second, after 20 second it came here. That means the body is retarding. With the increase in time there is a decrease in velocity and there is a uniform decrease. So it is uniform retardation. And how much is the retardation? Now slope perpendicular 50 by 20, that means 2.5 meter per second square. Acceleration will be, you have a triangle, so 50 by 20, that means 2.5 meter per, but you have to place a negative over here. Why you are putting a negative over here? Because it is retarding. So this slope means there is a negative acceleration. So that you have to use your common sense. So when with the increase in time, if the velocity is decreasing, there is a retardation. So A will be written as negative. So these are a few things. Suppose I get one more point over here, very important point. Let us see. Somebody is telling you ten seconds, then between this interval is 20 seconds and this interval is another 10 seconds. So now what type of graph it is? So it is a velocity time graph, isn't it? How do you recognize? Kilometer per hour is unit of velocity, and time second is unit of time. Now here first thing you do is 90 km per hour can be changed straight away to meter per second. So this is 25 meter per second. What you do, you write this in bracket and larger you write 25 meter per second. Now how to explain this graph? You will see when the time is 0, velocity is 0 because it's starting here. So you'll say the body started from rest and this is a straight line, inclined straight line. So it traveled with uniform acceleration, because what is happening, there is a change in velocity, and the straight line means what? Straight line means, what did I say? Velocity time graph, straight line means uniform acceleration. So it accelerated uniformly for the first 10 seconds. Then you see it is parallel to the time axis. That means it traveled with then zero acceleration for 20 seconds and then brakes were applied and it came after 10 seconds, it came to rest. So we will continue with some more graph. Thank you.